up, scholars? Last time we talked about rigid motion, which were rotations, reflections, and translations, which moved a shape from one space to another space, but kept it the exact same shape, didn't change its size, or any of its angles or anything. So today we're going to dig a little bit more into reflections. Let's remind ourselves, a reflection is a transformation which flips, doing a little flip, a figure over a line. And what did we call that line? It was the line of reflection. Line of reflection. And reflections are isometries. So a reflection is an isometry. What did that mean again? It meant it preserved the shape of the original shape. Kept it the same shape. So it's not squished up, it's not bigger than it was before, it's the exact same size, the exact same shape, it just moved somewhere. Let's talk about this theorem of reflection. Again, a reflection is an isometry. And here are some examples of reflections. Taking this segment PQ and reflecting it across this line of reflection M would give us this post image P prime, Q prime. You can also kind of think of it if you fold your paper, if you like fold your paper over that line. Where would it be? Be over there. Yep. Some other cases to look at. Here's segment PQ being flipped across line M. So P ends up on the other side. Q ends up on the other side. Or segment PQ here. P and P prime are in the same spot because P is on the line of reflection. And segment PQ here, this time Q is on the line of reflection and P gets moved over there. Cases to think about. Reflections and line symmetry. What does symmetry mean? You guys remember the law of symmetry? Right, we had law of symmetry and reflection and what was that third one? Started with a T. Transitive property, that's what it was, the transitive property. Yes, so anyway, we're talking about reflections and their line of symmetry. A figure in a plane has such line of symmetry if that figure can be mapped onto itself by a reflection over that line. I'm going to say over is a better word here. So a figure in a plane has a line of symmetry, if the figure can be mapped onto itself by a reflection over the line. Different shapes have different lines of symmetry. You can chop them up in different kinds of ways, different numbers of ways based off the shape. How many lines of symmetry do we have in these figures? Well, they're drawn for you, but the only way to chop this guy so that if I reflected it, it would be perfectly symmetrical across that line is this way. Think about if I tried to chop it this way. Okay, that's not, each of these pieces are not the same halves. Like that bottom half is not equal to that top half. But in this real line of symmetry, the right half and the left half are exactly equal to each other. So that's got one line of symmetry. This dude here, one line, two lines of symmetry. Again, if I chop it this way, The right and left are the same exact shape. If I chop it that way, the top and bottom are the same shape. There's two lines of symmetry. And this, what's this shape called? 1, 2, 3, 4, 5, 6. It's a hexagon. It's got 1, 2, 3, 4, 5, 6 lines of symmetry. Huh, I wonder if there's a relationship with regular polygons and their number of lines of symmetry. How does number of sides relate to number of lines of symmetry? Food for thought. Well, let's try some examples with our newfound knowledge. Example number 1. Triangle ABC is being reflected over the x-axis. Draw and label the image triangle A prime, B prime, C prime. Okay, we're reflecting across the x-axis. So I'm like folding this shape in my mind. Hopefully you're good at this mind gymnastics here. I want to fold it across this line. So I can tell that B is not going to go anywhere because B is on that line. So B prime is in the exact same spot. A, flipping over that line, definitely going to move. How far? Well, how far away is it from our line of symmetry? 1, 2, 3. So when we reflect it, it's going to be 1, 2, 3 units away still. That's our A prime. And our C, how far away is it? 1, 2 from our line of symmetry. So it's going to go up 2 more to make C prime. So let's draw our new triangle. Triangle A prime, B prime, C prime. We see that it's exactly the same shape. It reflected over this line of symmetry, which was the line, the horizontal line, y equals 0. I know it's weird, it has a y in it and it's horizontal. You'd think horizontal is x-axis, but this line here goes through y equals 0. And the y value, that guy is 0 all the time, so that's the name of the line, y equals 0. All right. We can use an arrow to show and describe this reflection. Triangle ABC is, what's that mean again? Mapped onto triangle A prime, B prime, C prime. Let's look at them, their coordinates of each of these points and see how they moved. Where were they? Well, A was at 1, -3. Where is A prime? It's at 1, +3. So interesting. Very interesting. Where was B? 3, 0. And B prime didn't move because it was on the line of reflection, so that remained 3, 0. And C was at 4, -2. And C prime is at 4, +2. So can we find a general rule for an x-axis reflection based off of these points as examples? Yeah, dude. X-axis reflection, we didn't change the x coordinates of any of these guys, did we? 1, 3, 4, 1, 3, 4. So the x coordinate's going to stay the same. Whatever x, y was of that original point, the post image is going to have the exact same x coordinate. But the y's, what they do, man? We went from -3 to 3, from 0 to 0, from -2 to 2. We changed their sign. So the y values became the opposite sign. Was negative, became positive. But the second the 0 sign didn't change. That's true, man, because 0 is not positive or negative. So it's kind of nonsensical changing its sign. It's going to be the same thing. All right. Well, I know you know what's coming next. We reflected it over the x. Let's do the same thing over the y. Okay? The y-axis. What's the equation of this line of reflection? It's x equals 0. Let's draw our image, A prime, B prime, C prime. A is 1 unit away from the line of reflection, so A prime is also going to be 1 unit away. B is 1, 2, 3, so B prime. You're correct. 1, 2, 3 units away. B prime, son. And C is 1, 2, 3, 4 units away. So C prime is going to be 1, 2, 3, 4 units away. And we have this really, really nice triangle. I mean, it's so pleasant. So super duper pleasant. Feeling good about it. All right, let's check out the coordinates. Where was A? Original A, OGA, was at 1, -3. And A prime became -1, -3. Where was B? At 3, 0. And where's B prime? -3, 0. I'm starting to see something. Things are moving in my mind, you know. And C is at 1, 2, 3, 4. That's at 4, -2. And C prime is at -4, -2. So what's our general rule for a y-axis reflection? Why, my dear, we take the x-coordinate from the original and we change its sign into the post image. Change its sign. See that? What once was positive becomes negative. If it was negative, it would become positive. And we did not change the y-coordinate. So that's the same. There's our general rule. All right. I know you know. We got some more examples to do. We got some more examples to do. Draw a triangle JKL, which has coordinates J at 0, 2, 0 for the x, 2 for the y. There's J. K is at 3, 4. Well, we lost a little line there, didn't we? And L is at 5, 1. There's our triangular. Ooh, great. Cool. Draw image. Triangle J, prime K, prime L, prime after a reflection over the x-axis. So we're reflecting across this guy, which just to remind ourselves that equation is y equals 0. So where's J going to move? Well, it was 1, 2 units away from the right reflection, so it's going to be 1, 2 units away in the post. How about K? Well, it was 1, 2, 3, 4, so 1, 2, 3, 4 units away here. And L was here we go, L prime, prime. And there's our nice, pretty new triangle. It's so pretty. It's so pretty. Where are new coordinates of this, you ask? Well, J prime, dude, is like, I remember, we've flipped it over the y, so we just changed the sign of the second one. So it was at 0, -2. And then we, same thing here, change the sign of the y coordinate. So it's at 3, -4, and L was at 5, 1. So now it's going to be L prime at 5, -1. Boom, shakalaka. All right. You are going to draw a new image. Triangle J double prime, K double prime, and L double prime after a reflection over the y-axis, which is x equals 0. That's the line. And you're going to find some coordinates, and you're going to list some different combinations of how you could have done that, and tell me, is the new image congruent or similar to the figure? You're going to finish these notes. I love you so much. Keep on that hustle. Good things